All right, so today we're going to review a little bit of linear, piecewise, and absolute value parent functions, and just how to graph them, transformation rules. So I wanted to review with you the three different ways that you can, or forms that a linear function can come in. I think you're all really familiar with slope-intercept form. So y equals 2/3 x minus 2. We know that 2/3 is the slope, and -2 is the y-intercept. So y-intercept and the slope. So the y-intercept is at -2, so I graph that first, and then go up 2 over 3, down 2 over 3. So that's the line, y equals 2/3 x minus 2. So slope-intercept form tells you the slope and the y-intercept. Point-slope form is going to tell you a point that is on the line and the slope of the line. So this number in front of the parentheses is the slope. So the slope in this case is -1. And the point in question is the opposite of what is inside the parentheses. Remember how a plus sign really means go to the left. So this is the point, -1 comma 3. So without having to convert this into slope-intercept form, I could start at the point -1 comma 3 and do my slope of down 1 over 1. And if I had converted this into slope-intercept form, I think you can see you would have distributed the negative sign, so your slope would have been -1. When you distribute the negative sign, this value would be -1, and you would have added this 3 to the other side, giving a y-intercept of 2. So whether you graph it in point-slope form or slope-intercept form, it's going to be the same graph. Number 3 is given in standard form. So again, you could convert this to slope-intercept form, but in standard form, a trick that you can use is you can plug in 0 for each x and y and graph the x and y intercepts. So if I plug in 0 for x, I'm going to have the y-intercept. Plugging in 0 here, I would get 3y equals 6. So that means that y would have to equal 2 to make the equation true. Same thing if I plug in a 0 right here for this y value. So 2x equals 6. So 2 times 3 is what equals 6. So my x-intercept is 3. So 0, 2, 3, 0, that would be my line. If I had converted this to slope-intercept form, I would have subtracted the 2x to the other side and divided by 3. So a slope of -2/3, I think you can see down 2 over 3. And I would have had to take this 6 and also divide by 3, giving a y-intercept of 2, which is exactly what I have. So these are just shortcuts. If you don't want to convert the equation into slope-intercept form, you wouldn't have to. All right, so here is some practice graphing with absolute value with transformations. So I would pause the video right now, try graphing 4, 5, and 6 on your own using the transformation rules, and then check your answers in a minute with this video. So pause the video. And here are going to be my answers. So my transformation here, I'm going right 2 and I'm going up 1. So right 2, up 1, this is a V-shaped graph with a slope of 1. So there is my absolute value transformation. Let's see, this is an absolute value. It just has a slope of 1/2. So I'm going to start at the origin, 0, 0, and go up 1 over 2. And let's see, this is a flip over the x-axis, so it's going upside down, and it's going left 4. So if I start left 4, oh, and it has a slope of 3. So I'm getting flipped over, and I'm steeper by a slope of 3. So down 3 over 1 would be my absolute value steeper graph. So graphing piecewise functions, you may not be that familiar with. But basically, it gives you a domain and the function within that domain, and then another domain that has a different function. So what you can do is you can start by graphing the whole line with pencil, and then you can erase part of the line. So that's what I'm going to do here. So the line is 2x. So it has an intercept at 0, 0 and a slope of 2. So now what points do I want to keep? I want to keep x is strictly less than 0. So I actually should have put an open circle at 0, and I'm keeping everything to the left of that x value of 0. So these points I can erase because they're not on my graph. An open circle means that you do not include that point as part of your function. So the second part of the graph says graph the line x plus 3. So I start at 3, and I'm going to graph a slope of up 1 over 1, down 1 over 1. And then looking at the domain, I only want to keep the x values that are greater than or equal to 0. So that would be this direction. So filled in circle, and then these points, this eraser is not good. There we go. So that's kind of the left and right hand side of that piecewise function. All right, so I was going to have you do this as guided practice, but I think I'm gonna have you do it and then pause it and then check your answers for each of these. Because I was not going to have you submit a picture of your work today. So this way you'll be able to check your answers as you go. So you should be pausing the video. I hope you paused the video. Closing the window did nothing to help the light. I don't know where the glare is coming from. So I hope you paused the video because now I'm going to tell you the answers. So do it on your own first to make sure you know what's going on. All right, so this time 2x minus 1, and it's for the x values that are less than or equal to negative 2. So 2x minus 1. So I'm just going to plot a few points till I see what is going on here. All right. I don't want to lose my computer off the edge. Let's see, x is less than or equal to negative 2, so I need to go all the way over to this point right here and then continue downward. So let's see, I'm going to start at this point because that has the x value of negative 2, and then I'm going to continue downward from there. So all these points have to go. All right, and then my other function is a horizontal line because it's y equals 4, and that is strictly greater than negative 2. So I'm going to go to the point negative 2 comma 4, put an open circle. And then I'm going to go all the way over to 2 and put a filled in circle. And that is a horizontal line. And that's the whole piecewise function. Example 2, let's see, negative 2x for x is less than or equal to 0. So I'm going to plot the point 0, 0. And this time it has a slope of negative 2. And x is less than or equal to 0. So let's see, negative 2 actually goes in this direction. So it has a slope of negative 2. That's actually a negative slope because from left to right, it's coming down. And it stops at 0. And then when I go greater than 0, I have a slope of a half. Now, because both of these have a y-intercept of 0, I can just leave that filled in right there. It's technically an open circle for this part of the function. Filled in kind of overrides that. So I'm going to do a slope of up 1 over 2, and it's going forever in that direction. Let's see, example 3, graph the two linear functions and find the point of intersection. So I gave one of them to you in slope-intercept form, and the other one is in point-slope form. So let's see, negative 2x plus 8 So I'm starting at a y-intercept of 8, and I need to go down to over 1. I'm not sure how far I have to go. And my other line starts at the point positive 4 from the x, negative 4 from the y. So I'm going to plot 4 comma negative 4. And it has a slope of 2. So up 2 over 1 is probably right where they're going to intersect. So it looks like they have an intersection point at 5 comma negative 2. So we could check if that point works in both equations. So that would be, let's see, if I plug in 5, I get negative 10 plus 8, so that's negative 2. And if I plug in 5, I get 2 times 1 is 2. So y would have to be negative 2 to make that true. So I know I got the right answer. And example 4 in your video for today, let's see, graph the absolute value function. For what values of x will the function's graph be below the x-axis? So I'm going right 3 and down 4, right 3, down 4. So this is an absolute value graph. So I'm actually going to put my dots because I want to know when is this graph going to be above or below the x-axis. So the graph goes forever, but they want to know when is the graph below the x-axis. So it's below the x-axis between negative 1 is strictly, let's see, less than x, strictly less than 7. So that's when it is below the x-axis. So now you do not need to submit a picture of this worksheet 008 because we just did it and checked it together, but you are going to have to submit homework 1, and you should have time to work on that during class.